Okay, thank you very much. That's it. Yes, it was thorough research, but what I'm talking about today has nothing to do with my work, with my company. It's some stuff that I've been only doing on my private, my free time. So I'll be talking to you about, hang on, yeah, looks good. I'll be talking to you about LLM-based development. As you know, LLMs are large language models, and it turns out this is not yet a thing. So you know, so this is not an established term yet. This is just what I am calling the stuff that I'm about to show you during this talk. And actually, for a really long time, and you know, since the release of ChatGPT, a really long time means a couple of weeks, I was quite convinced that this stuff is, you know, something that's brand new, and people haven't known about these things yet. So I was quite convinced that this is, you know, that this would be something entirely new, or if it's something entirely new, at least it's something that hasn't received enough public attention, as much public attention as I think it would deserve. And I was so much convinced that it's new that I actually ditched another perfectly cool talk that I was supposed to give here today. And you know, after talking to the conference organizers, I decided to talk about LLM-based models. The other talk that I ditched was about to be about quantum-inspired machine learning. So I'm originally a quantum physicist, and for me it was not imaginable that I would be able to find a topic that is even cooler than quantum-inspired machine learning. But I think I was able to find one, and you have to judge if it's true. Anyway, I'd like to apologize to all of you sitting here because they were expecting this talk. So if you're looking into this talk, just come up to me after the session, and I will be happy to share with you the things that I was supposed to talk about today. So anyway, the switch of the topic was for me quite challenging as well. That's because this talk is a talk that I have already given once or twice, so you know, to have been a small effort for me to freshen it up for today. Instead, I decided to talk about something that was entirely new to me until a few weeks ago. And as a matter of fact, during the last several weeks when I was working on this talk and some other things related to this, I learned so many new things, and much more I learned about other things that I don't know yet, that I have to admit in awe that I know that I know nothing. So my deep dive into LLMs basically began around a month and a half ago when the ChatGPT API was released for public access, and I should specify it's not a deep dive into LLMs, but into the usage of LLMs, how we can use this in apps. And since then, I've learned so many things and learned about so many other things that I do not know that I have to go full circle, you know, on this issue. And what I'm basically doing now is confessing that I'm more or less a beginner in this field, LLMs and the usage. So I'm more or less a newbie. As I said before, I was just doing this in my free time. And I thought it's interesting enough such that I present this topic here. So what am I talking about today? What is this? And I have to admit, it's not one of the amazing tools that have recently attracted so much interest. It's not trying to tackle artificial general intelligence like AutoGPT or Baby AGI are doing. It's not an incredibly well-performing open source large language model like Llama or Alpaca. And it's neither an easily accessible LLM tuning framework like Dolly. And maybe it's more similar to another quite famous tool, LangChain, because it's trying to optimize, you know, the efficiency efficiency of the developer. It's trying to make things easier, and it's trying to abstract away tedious work that's not so much fun, typically. So what is it, and how did it come about? So it started with something that I had on my mind for a longer time, but I just couldn't implement it due to lack of knowledge and lack of tooling. It's something that several customers or potential customers of a side business that I'm doing separately have mentioned over the last few years, but a few years ago, or even a half a year ago, there was just no way for us to implement this thing. So what is it? It's something that I would describe as an intelligent voice bot, and this voice bot should be uncanny, and it should be able to perform various tasks. And most importantly, it should be able to schedule an appointment on the phone. So it's an appointment voice bot. So how would you do this before the arrival of ChatGPT? So before ChatGPT, you could use something like Google's Dialogflow, which is known to be a task-oriented dialogue system. So you could use that, or you could use other tools like Rasa is also a task-oriented dialogue system. And these tools are, I'd like to say, legacy tools that are highly complex, and it's really hard to set them up because you have to set up the dialogue flow manually, and you have to account for all the corner cases that can pop up in your conversation. So using these tools is really difficult. Or it was for me, maybe other people have a different opinion, but for me it was just too difficult. And I just skipped that use case. However, for me, the entire story changed dramatically when ChatGPT popped up. So all of a sudden it was really much more approachable to implement the appointment voice bot. Or at least I thought so in the beginning. Because as it turns out, you still have to put some effort and thought into developing this type of system. So how can we implement an appointment voice bot? And maybe let's start with the architecture. So what you're seeing here is the system boundary of the voice bot. And this document here is basically stands for whatever we would program the system to be to ChatGPT. So it's basically the prompt and whatever else we would have inside. And how does this work? So this other app I'm talking about is an app for doctors, and their customers are obviously patients. So a patient would call up and be connected to the system, and his voice would be transcribed to text and somehow prepared for input into the large language model. On the other hand, when he calls, the system gets triggered, and what it does is to use the original prompt to set up the API call to OpenAI. So this is the input for OpenAI, and then we send it to the OpenAI API. Then ChatGPT, unfortunately, right now I only have access to 3.5. I'm not on the early access list to GPT-4. Does something and spits out an output. The output goes back into the system, and now we have to decide what to do with this. So there are two options that we can do with this output. So either we can pass it as it is, because we cannot improve it because it's ChatGPT. We can pass it as it is to the user, or if we have some hint within this output that we must do something outside of our system, maybe look up time slots in the calendar or book an appointment in the calendar, we have to decide to make an API call to a calendar API, whatever we're going to do with this calendar API. The calendar API sends the answer back to our system. It is then processed, so typically this is a JSON payload, and it is then processed somehow to be inputted into the ChatGPT system. And then we have this loop a few times, so patient talks. So actually this is missing from the loop, because some of these inputs also go back to the user. So we have this loop a few times, and our goal is at the end of the conversation to have an appointment scheduled. So this is the basic architecture. It's not very complex. So now let's look into how such a conversation typically look. And I have 3 examples. I hope I'll be able to go through all of them. The first one is certainly the most impressive one because it's a GPT-4 example, but so this is not an automated thing, okay? So I had to use the web UI to come up with this example. And we have 3 different roles in this example. And you have to remember these icons because they will be showing up afterwards. We have what I call the controller user. So basically in the ChatGPT API, you have 3 types of inputs that you can pass to the system. The first one is the system input, and this is the most unusable one because in GPT 3.5 simply ignores it, so you can forget it and never use the system user. In GPT 3.5, it's supposed to work much better in GPT 4, but I haven't tested yet. So you have the system user, forget about that one. You have the user, which is the user input to the model, and you have the role assistant, which is what the model spits back to the user. But in our case, we have 2 users. We have the controller user, this is what my app is saying. We have the GPT-4 assistant, and finally we have the real user. So this is what the real user, the patient, is staying on the phone. And what we'll be looking at now is the heading path. So it's the path where everything worked out perfectly, especially because we're using GPT-4. So let's start the conversation. We start the conversation with the prompt for the large language model. So I don't expect you to read all of this, but maybe let me point out a few things. So when you call the API, by an API call, you can pass a parameter which is called the temperature. And the temperature, if you set it to 0, it makes sure that the model has spits out replies that have as little variation as possible. You can increase it to higher values, but in this case, we want a deterministic system that's not coming up with stuff, that's not generating, and especially it's not hallucinating. So you can set the temperature in the API call by a JSON field, but if you're talking to the web UI, you have to do it like this. You just say in this first line of the rest of this conversation, set the temperature to 0. This is what you can see that I'm using the web UI. Okay, then the next thing that's different with the web UI from the way we would call the API is how the conversation flow goes. Because in the web UI, we have intermittent sentences and responses. So the bot has to say something, and the user says something, and the bot says something, and so on. In the API, we can completely mix and match these things. So you can have the system say 5 things behind each other, and then have the user say 2 things. But since we're using the web UI, we need this intermittent flow. So in these sentences, I'm basically telling ChatGPT, look, the next output that you give me should be just this total that is all caps ChatGPT ready. This is just for the purpose that you signal to me that you're ready, you're ready to go, and this is not addressed to the user because you are a chatbot service using the backend of an appointment scheduling app, blah, blah, blah. Then the next bit of the system, look, today is Saturday, whatever date we have here, it's an older date. Then we give it a bunch of days where the doctor still has available appointments. These are things that would come out of the calendar API, out of the Google Calendar, typically. And then we are passing a set of rules to ChatGPT, and you can write them down one after the other. And this is a longer thing, and I didn't have time or space to put it here. But what basically these rules are saying, try to achieve a goal, and when you have achieved a goal, when you have, for instance, found the date where you have an appointment or where the patient can come to the doctor, then give me a token that I can recognize in my controller app. I'm parsing for this token, and accompany this token with a payload, for instance, with a negotiated date, without any other text, ideally. We'll see. GPT-4 obeys this rule. GPT 3.5 simply ignores it. So this is the original prompt. And now let's see how the conversation goes. So GPT says, ChatGPT ready. The patient is saying hello. GPT answers, quite nice answer, because I told it to just provide 3 days as options for the patient. It's just providing these 3, even though I had 5 originally. And this goes quite smoothly. The patient says, okay, on Wednesday I'm free. And now GPT knows we have found a date that is feasible, so it spits this token that I can pass forward with the payload, with the date. Then my control app knows, okay, I have to go ahead and call the calendar API, and I'm asking the calendar API which time slots are available on this date. I have instructed GPT previously that it shall listen for this token and for the time slots that it would receive from my app. So GPT understands that and provides exactly these time slots in a separate chat that doesn't contain any tokens, so I know I can send this back to the patient. And the patient, it asks this question first half or second half of the day. It was instructed to do so. The patient says, in the morning, please. GPT says, okay, in the morning we have these 2 slots available, which one would you like to book? Patient says, I want to book the later one. GPT says, great, we have one. It can identify the one to book. It's 12 to 12:30, so it sends me a token with this payload, the starting time of the appointment. I go to the API, I return appointment book. Here you can return other stuff like could not book the appointment because somebody else booked it in the meantime, or just error message. However, this is the happy part. Everything goes right in this example. So ChatGPT is able to tell the user that it's great news that one has been booked. So this is the happy part. Patient is impressed. Let's look at another example, this time using 3.5, again in the web UI, because the web UI actually is performing a little bit better than the API. And we have again these users, the controller user, the GPT 3.5 assistant this time, the real user, and this is the not so happy part. It doesn't work perfectly. Let's dive into it. This is exactly the same like before. You see it's a different symbol. It's for 3.5 rather than for 4. ChatGPT ready, hello, may I assist you? I have some terrible pain in my back, so this is a variation from before. ChatGPT should be able to handle this. Well, I'm sorry to hear that. We're here to help you get an appointment with the doctor, blah, blah, blah. What date would you prefer? So the patient says Wednesday, okay, and this is the first thing where it goes suboptimally compared to GPT-4. It gives me this token and a date. As you can see, this is not a nice date like before. In the date format, it's the week of the date, but the app can handle this because it knows it's the next Wednesday. It can handle this, and we can also ignore this line here because we're just parsing the text for the token and for the payload. So it's fine until now. Then the app returns the time slots to ChatGPT, and here you see where it goes suboptimally. ChatGPT says, thank you for the available time slots on Wednesday. May I ask if you prefer the first or the second half of the day for your appointment? So this might be a little bit confusing for the user because the patient calling on the phone didn't provide any time slots. But whatever, we can just deal with this, and the patient can say, okay, it's a bit strange, but maybe I'm just answering that I'm available in the morning. Okay, ChatGPT can deal with this. Again, some text here that it's not supposed to be here, but in the morning. So you see what it's doing here. In the morning we have 2 appointments because 12 is also considered to be in the morning. So ChatGPT just decides that in the morning means the patient has already agreed to the appointment at 10:30. And it's not so horribly wrong. It's actually a good outcome because the patient wants to have the appointment on Wednesday in the morning, so 10:30 is not that bad. The API books the appointment, ChatGPT confirms to the user that it has been booked at 10:30, and the user goes, okay, I didn't agree to 10:30, but whatever, it's Wednesday morning, so let's go with this. So now let's move to the third case. And this is the ChatGPT 3.5, this time with the API, not the web UI. We have the 3 users, and this is the frustrating part, and you'll see why. The prompt is more or less the same like before. The only difference is that we got rid of setting the temperature in the beginning because we can pass it via the API, and we get rid of this ChatGPT ready step in the beginning because we can pass 2 user messages right behind each other. So we pass a user message from the controller, and we pass a user message from the actual user who's saying hello. Let's see how this goes. How can I assist you today? I need an appointment. So this is actually the variation that I did. The variation in the prompt is not meaningful. If just making the variation, the change in the prompt, and providing the same input here like in the one before, would yield the same result actually. But this is where I made a change in the user statement. I need an appointment. Okay, ChatGPT set me to have me schedule the appointment. When would I like to schedule the appointment the earliest possible, please? Okay. So the earliest possible dates are these ones that were provided in the original prompt. Which one works best for you? This is the same, Wednesday, small variation please. And this is where it goes wrong this time. So ChatGPT sends in the token, which means I'm supposed to use this answer to go to the API. And it hallucinates time slots, because at this point, ChatGPT doesn't know anything about the truly available time slots on Wednesday. So this is hallucination, basically. But let's go with it for a moment. So I find the token, so I go to the API and return the time slots this year. And watch what ChatGPT is doing. So first of all, it returns me a token because it says the appointment is found and it's ready to be booked. So this is a hint for me that I'm supposed to book the appointment in the calendar. What it's dealing correctly with one thing, namely with the time. So it gets rid of the original hallucination 9:10. It provides the correct time at 10:30 a.m. on Wednesday. And the rest of this message you can ignore because it's not supposed to be sent to the user, it's for the controller. So appointment slot ready, found, ready to book. I go to the API, book the appointment. So what does ChatGPT say? Great, your appointment with Dr. Smith on Wednesday at 10:30 has been successfully booked. We look forward to seeing you then. So this is then returned to the patient, and this is a bit strange for the patient because the only input he has given was Wednesday. That didn't say anything about the time or the half of the day. So the user is maybe just a bit angry, or maybe he's outright frustrated with this result. And that's basically, so I describe this flow, and what you have seen here is what I call LLM-based development. Because the LLM, the large language model, is at the core, logic component in my app. And developing these things is quite challenging because there is a part that is highly unreliable, and that's the LLM part. And how do you program that part? You program it with the prompt. And basically the original prompt is my programming language for the LLM. And as with any other model development, you have to test your code. And when you make some changes in your code, like in the prompt, you have to do regression tests and be sure that whatever change you have made doesn't result in everything going horribly wrong afterwards. So this is the problem. We have to somehow make sure that the app behaves reliably. And what is the solution? Well, the solution would be a testing framework for LLM-based development. And this is actually what we've been working on. We plan to open source this as soon as it's ready, but right now it's not showing yet. It's not producing the results that we would like. But we have already set a placeholder for the GitHub repo. As soon as we think we can publish it, it will be available at this URL. And let me explain briefly how this testing framework for LLM-based development is supposed to work. So you saw that in our conversation before, and we can break down this testing framework into a few steps, into a few phases. So we have a first phase, which is what I call a chat phase. So in the first phase, the LLM talks to the end user and maybe try to negotiate something. And in the testing framework, you can define this chat phase and give it a goal. The goal would be to find a date. And you know when the phase is over because it has reached a milestone. In this case, the milestone is when the LLM spits out a token. I'm calling it apt token here. Before we had something with get date or date found or something like that with a payload. So the controller, and in this case the test framework, is looking for this tag and the payload and the messages that are provided by the test framework. So it looks at each message and then it has to decide, has the goal been met or it hasn't been met? If it hasn't been met, you go back to the chat phase and you do the checking with the user. If the goal has been met and you find a tag, this tag with a payload, then you can make an API call. And the API call is a different phase in this entire flow. It has an action, in this case get the time slots, and the result, as we had before, it's a certain token with a payload. And this thing can get fed into ChatGPT, into the model, into the chat phase, where the model again tries to negotiate something with the patient with a different goal this time. So the goal now is to find a spot, and the milestone is to spit out the specific token for the app to understand what's going on with this payload. Again, here we have another decision, a split. If the API call yields an error or an empty list of time slots, we have to go back here and renegotiate the date. Otherwise, if we have a list with a length greater than 0, we go to the chat phase, and then the model spits out something. Again, we test for the goal. If the goal is not met, we go back to the chat phase, and they're chatting back and forth until the goal is met. We see the token with a payload, and we can go to the next API call. So that's basically the flow, and what you've seen here is, for my, as far as I can judge, one of the most simple flows that you can have in a conversation, because this goal is quite simple. You have to establish a date and an hour. But in general, you could come up with tasks that are much more complicated than this one. And basically, the entire thing is that you don't want to do the testing manually. You want this framework to take care of you. And what is the most intuitive thing to do in this case? You want, the user, the party, the user, you want that to also give a chatbot, an intelligent chatbot. So you have the proper chatbot, and you have the user testing chatbot that gets its instruction, and these guys can talk to each other. You run this many times, dozens of times or hundreds of times, and in the end you get a statistic, how many times was this successful, how many times did I achieve the goal, and you would want that statistic to be close to 100%, such that you can say that your app is reliable. So that's basically the gist of it. We are in an early phase of looking at these things, so we're doing it on our free time, so we don't expect, to be very fast, but we're still quite fast. And if you want, you can stay updated on this LLM-based development testing tool, either this repo that I already shown you on the other slide in the footnote. What I've been doing recently, since LLMs came up, and ChatGPT specifically, is to publish on Medium. So I already published 2 articles on ChatGPT and this type of conversations between different agents. So you can go here and subscribe to this channel. Stay tuned for more. It will be suddenly announced on Medium. Or if you don't care about these platforms, you can just go on LinkedIn, because I'll make sure to publish everything on LinkedIn. With this, I'd like to thank you for your attention and open to questions.